So last week we saw all partitions like static partitions, dynamic partition creation. We also saw static and dynamic partitions together. So I have a data set in MySQL, which is a complete data set. So let's create a partition data sets into Hadoop and create a Hive table on top of it. Okay, so let's first go into Hive. So are you guys able to see my screen? Okay, so let's go into Hive. And then use training. So here to see list of databases we use show database, and to see list of tables we'll see show tables, and to see table structure or metadata we use describe table name, and we can also use another two types of describe to formatted describe, and also which will be in a formatted description way, which is this you can see as formatted. You can also see as describe extended. So this is describe extended. So and also we have something called create table statements as and like. So what create table statement as and like does is, if you want to just copy the schema, you will do create table like, and if you want to copy the whole data also, then you do create table as. So let's take an example. Use training. Okay, so show tables. So we'll just take this static partition table. So create table sp table. So what we'll do is we'll just create table structure as spdp. So create table. We are going to do as, so create table name sp, and then we can also specify location, different location for this. Let's go ahead and do that. Location user Shiva, yeah. And then we'll do as select. We are going to do the same select query. So this is a static table. We'll just do. We can also specify only certain number of columns or all columns. So we can just do select star from, and after this we'll do create table like. So difference between as and like is as will copy the data also, like will only copy the metadata. So we will see that data also. And then after this we will see creation of different file formats. Until now also okay, so it's done. So let's go ahead and see the data. So let's go ahead and clear this. Hadoop -l space. We see data in here, right, in this location. So let's go ahead and create table like. Create table cd like sb location. We will specify some different location like. Then we will do just like star from. So we are using, instead of as, we're using like. So okay, create table like. Oh, sorry, don't need to specify location. Okay, so let's see. So user Shiva CTS like. So you don't see any data. So what we did is create table, table name like this table, and you specify everything like location and everything. So after specifying like table, we can specify location. We can also specify stored as, like if you want to store it as Avro format, if you want to store it as Parquet, if you want to store it ORC, you can specify different file formats just before location. But here in like, it did not create data, it just created metadata. So that's two types of create statements. Now let's go ahead and see creation of different file formats like Avro file format, Parquet, ORC, and sequence file format. So let's see. Let's clear this. Okay, so let's see, create some data. So first, I'll go ahead and create different file formats. I'll create table statements for different file formats, and then later we will see how to copy data from text into those file formats. So this is a sequence file format I'm using. This is exactly same like text file format. The only difference is when we're specifying another file format, we have to change the sequence file in here. I'll tell you the difference between different file formats in later class, but today let's just concentrate on how to create different file formats table. Then I'll explain you what's the difference between other file formats and when to use it. So if you want to use sequence file format, all we have to do is to specify sequence file format. So I'm specifying sequence file format here. That's it. And the same thing with
Shiva,
yeah.
there is one question. Like,
So we have created this four tables. One is ORC by storing it as ORC, Parquet by stored as Parquet, Avro stored as Avro, sequence or as sequence. So now let's take an example and insert the data into those one of these tables. So I will use Parquet as an example, and others should be the exactly same. So now if you see, select star from Parquet table, it's empty because we didn't insert any data. All we did is to create table statement. So now we have data in this np underscore table, right? What happened to this table? np underscore table. Oh, give me 1 second. I have to move this data out of it. So np underscore table. Shiva scoop stage. Okay, so I have this data, but I actually, by mistakenly, I copied these two folders into the same data. I'll just move that out. FS copy. Move. Copy. Sorry. So I'm moving out this Avro schema folder out of that, and I'm moving into user Shiva. I'm going to do the same thing for another folder. Now if I query this scoop stage, it will have only same data set that we had other day. So we have only part. Now let's go ahead and query table. Let me tell. So I have this data now. So in this table, I have 1000 records. Let's go ahead and insert this data into Parquet format. So how do we do it? So it's very simple. Just do insert into Parquet table and then select all the columns that you specified in Parquet table column format. That's important that we specify it in the same order. So in Parquet table, if the first column is first one, then we have to specify this as the first column. So this is important. It all depends on us how we specifying. If we specify wrong column name, it goes into the wrong field. And then we are pulling the data from NP table, and then let's just pull 100 records. That's okay. So we are doing insert into Parquet table. We are selecting all the columns that required, and then we are selecting it from no partition table and limit 100, and then do the sys. While it's running, let it run. Okay, now its data is inserted. So let's see. Let's see this. Hadoop select star from Parquet table. So it pulled all this data. So Parquet table has so let's go ahead and just I'll explain you a little bit about Avre and Parquet because anyway we are using that, right? So let's I'll explain you. So Avro file format is a data serialization framework, and all this this Avro is developed by Apache Hadoop. It's a open source. So what Avro does is Avro is a data serialization framework. So it uses JSON schema format to define data types and protocols. So that means all the data types that we specify let's say, for example, I'll take an example that we created in here. So these are the data types, right? So all these data types are specified in JSON's file format, and it's specified in a separate schema file. So that's, and what Avro can do is Avro can have is a data file, and it can have a schema file. So all the data types are specified in that schema. So whenever you run this data, it will check against that schema and get the data types and run the queries. So it's mostly since it's used the JSON data structure, so it has a schema evolution. When I mean it's a schema evolution means like today we can have like 10 records in that schema file, and I will show you the example of how that schema file looks like. So this is how the schema file looks like, JSON schema file. So today I took the same exact example of our table. So like company and column names, you see all that. So each column is defined in such a way that it has fields, and fields have name, which is nothing but column name. It specifies as ID, and its type is it defines itself as what type is that ID. It's an int, string, long, and everything. So name fields are like name, and it will keep itself in one set, like here. Here, this becomes one set. The same thing also starts in here for this one. And the column is first name, and then another column is last name. So this is nothing but a JSON file format. And then the advantage of Avro is, let's say tomorrow, if you scoop the data with extra column, let's say there is something called company 2 or company 3. So today's data will have only this data sets. So tomorrow data set, when you scooped it, it will have an extra column with company 1 and company 2. So data evolution is nothing but if you add more columns to Avro, it can still read the previous columns. The only difference is when you add new columns, you just have to specify here something like name. You have to specify name as a column 1, and the only difference is over here you will specify something called default. Default is nothing but what default you want it when it try to query the older partitions which doesn't have this column name. You can just specify it as null. So once you specify this, and if you query the Avro data, it can query the older partitions and also newer partitions. So that's called schema evolution. It won't break the schema. So when you add the new column in here, it can still query older columns and new columns, but older partitions which doesn't have this column, it will just default to the value that is specified in here. So that's the advantage of Avro schema. So for now, just thinking that Avro is a data serialization framework which uses the JSON for the schema specifications for data types and protocols. So similarly, we have something called Apache Parquet. Let me show you Apache Parquet file format. So when we specify, give me 1 second, guys. So so okay, this Parquet is a columnar storage format, and this columnar storage format increases the speed of the queries when compared to the Avro. I'll show you with more examples, but let's think in the Parquet. It doesn't have the schema evolution because the Parquet doesn't store the schemas in separate file. Instead, we write the schemas in the same create table statement, and that's how it stores it in the table. It doesn't store the schema in different average schema file. So it's for now. Just think that Parquet is a efficient columnar file format. So when we have a certain use case where we are using the columns, certain columns only for the group by, for sum and counts, that's when the Parquet file format is faster. So they both are used for different scenarios. Avro is used if you have lots of schema evolution, and if you're doing it on the select star versus only specifying certain columns, then Avro is good. But if you're using a use case where you're only have queries always, even if you have 365 columns in the table, and if you just query it on only certain number of columns, and if you use some group wise and only that's calculations on certain columns, then we use Parquet file format. And Parquet file format is generally takes less compression when compared to Avro. So I can give you a little bit more idea of that. So let's go ahead and just do. So we created Parquet file format in here. So this is so we have seen a different file format: sequence, Parquet, ORC, and ORC is also similar to Parquet. It's a row columnar database, but Parquet is supported by Cloudera, and ORC is backed up by Hortonworks. So we saw loading data into Parquet. Now let's go ahead and see. Let's go ahead and scoop data in partitions. So in partition. So now, so what we will do is we will actually create a Avro file, Avro table, and underneath that Avro table, we will go and scoop data and put it into partition. So for that, let's go ahead and create an Avro table, and it should be partitioned by department. Okay, so then use training. Then I'll go ahead and create some. Sorry. So okay, so now this is an example of Avro table. So I'm create external table, Avro table, partition by department, and then sorry, this should not go. Give me 1 second. Use training. So here, when you specify Avro, we don't have to specify the list of columns like how we specified in Parquet or text format, because all the columns can be specified in this AVSE schema. all the data types and the metadata can be specified in this schema. So all we need to do is we'll just specify it as Avro, we'll specify location, and the schema file we will specify it in here. So in here I'm specifying schema is in this location and data is in this location. So data, and this is schema. And then when we scoop it, partition column name department conflicts with table. Okay. Oh, I should not be creating. Let's create into separate file. Avro1. Okay. So I'm creating Avro1. Okay. Close without saving. So I've already created a Avro schema and moved into that location. But the problem is this Avro schema should not have that column name in that, because we are using that column as a partition. So let me see. Okay. So I created this table without a partition, so without that column name. Now so we're planning to move the Avro schema into this location, Hadoop FS-ls. So before creating a table, you need to have a before moving the data, we need to have a schema already existing in that schema file. So that's what I'm trying to do, is to create a schema file now. So here I already created schema file, but it has a department in there. So I'm going to delete that schema file and then freshly move this. I will delete it. And then put the modified schema name in there. So modified schema is this ABSC, new one. And then I'll put it into this location. Here, and then after moving that file, let's go and check that file and make sure that that department should not be in the column. So as I told you earlier, when in the partition, so if the column you're specifying as a partition, then it should not be in the list of data types or list of the column names. So just go.absc is trying to open that file. So now Hadoop FS-cat. You see this in here, we have a company and there's no name company. Yeah. So we have a company, but there is nothing for department. So let's go ahead and use this to create our Avro table. I use training. Now it got created. So it's the reason we got error earlier is this Avro schema also had department specified in the list of columns, but since we are using partition as department, that Avro schema should not have that column specified in there. So now we did not get any errors. So let's go and query this table. So here it's saying external table and it's Avro. It says training. It's partition by string. Avro schema URL. It's showing to this location and data path this location. So, and it also shows input format, output format is nothing but SERD serialization. It shows that it's Avro. So what we will do is, in this location, now we will copy, we will scoop data from RDBMS and put the data in this location. So while copying the data into this location, we have to make sure, see now we don't have any data, but in this location, when we scoop the data, we have to make sure that we scoop data into partitions. So that means under Avro 1, let's say if I'm doing partitions based by departments, based by, where is that file? So based by department. So when we scoop the data in based by department, so it's our responsibility when scooping, we have to make sure it goes into this location. So when we scoop data, we have to specify location as this and add another location to next to it / department is as. So we have to specify department as this partitions. So in next, so for that use case, what I will do is I'll take a bigger data set in RDBMS with 1000 records with all the data in it, and then scoop the data from partitions into Hive table, and we will scoop into Avro data format. So that I will let's do that in next class. So that's all for today's class, guys. So tomorrow we will see scooping partitions